Hello. So this video is going to focus on how to solve two right triangle problems using trig ratios. Okay. So we'll read through the problem. And here we have standing on one bank of a river, a surveyor measures the angle to the top of a tree on the opposite bank to be 35 degrees. She backs up 72 feet and remeasures the angle to the top of the same tree to be 14 degrees. How wide is the river and how tall is the tree? So I just want to make a couple points here. One, I don't have a picture here yet. A lot of the examples have pictures, but you do have to really build your skills on drawing a picture. A lot of problems won't have pictures, and you got to learn how to decipher that and make a picture. Secondly, this problem is about indirect measurement. You have a surveyor who's trying to find out what's the width of a river, and for whatever reason they can't traverse the river. So they're really using math, which is incredibly powerful and honestly pretty easy, to go ahead and do this. So math rules, what can I say? All right, so let's go ahead and see if we can look at the picture what we would make here. So again, you don't have to be fantastic artists, because I sure am not. You've got some kind of a tree, right? And you've got a river. And what this person does, now there is a height to the person, and technically if the orders of magnitude aren't tremendously different, the height of the person does matter. You'd have to add that in. But really all these problems assume that the person's like a dot. So here's a person. And what they do is they sight, right, they're standing at the edge of the river, and they sight the top of the tree right here, like that, okay? And what they're trying to find is the width of a river right there, okay? That's what they're trying to find. So here's your right angle right there, okay? So we don't know this width of a river, so we're going to call it X. And we don't know the height of the tree, so we're going to call that H. All right. Now what happens is this angle in here is 35 degrees. And then what the person does is they back up 72 feet. And I have no idea in relation to X how much that is. I really don't know. So I'm just going to draw this out like this. Okay. And what they do is they sight the tree again. Top of the tree, same place. Boom. So they moved 72 feet back, and then this angle was found to be 14 degrees. Okay. So now what I'm going to do is, we've got it here. This is one right triangle, and this is another right triangle. So I'm going to draw the two right triangles. So one of them is like this, right? 35 degrees. And you have H, the height of the tree, and X, the width of the river. Then you have another triangle where the height of the tree is the same, but the person moved back a lot more right here. So this is now 14 degrees, right? They're further away, so the angle's smaller. The height of the tree is the same, and now you have X plus the 72 feet that they walked back. So those are your two triangles. Now that you've got your triangle set up, what you want to do is, relative to the angles, each angle given, label the sides of the triangle that you're working with, and then decide what trig ratio you're going to use. So relative to this angle, this is the adjacent, X is the adjacent, and H is the opposite. Relative to this angle, 14 degrees, X plus 72 is the adjacent, and H is the opposite. Okay. All right, so now we have our sides labeled. Pause for a moment and just think, what trig ratio would you use? All right, and set it up. So I would say tangent of 35 degrees, right, is equal to opposite over adjacent, which is H over X for my first triangle. And for the second triangle, I would also use tangent, because that's opposite over adjacent. So tangent of 14 degrees is H, opposite, over adjacent, X plus 72. Okay. So there you go. There's your two right triangles And by the way, here's your right angle. Okay. Now, this really should be kind of parallel, I think, to this. Make it look right. All right, so here, honestly, you finished your trig. The rest is algebra. So what do we have here? We have two unknowns, h and x, but we also have two equations, so we can solve them simultaneously. So that's what we want to do. So I do point out, though, that the trig is done if you have trouble. If this was easy, your trig is fine. And if the rest is hard, or there's some part of the rest that's hard, what it means is you need to work on your algebra. And it's just a skill. You just, like anything else, go practice it. All right, so let me get a fresh piece of paper here. These really bleed through. All right, so let me just rewrite these again. So from 1, I have tangent 35 is h over x, and from 2, I have tangent 14 is equal to h over x plus 72. Now, if you can, go ahead and pause the video and solve this. Go ahead and work with it. All right, so what I'm going to do is go ahead and do that. I'm going to solve for h for both of them. So I'm going to multiply this side, both sides by x. So I'm going to have x tangent 35 degrees equals h. And here I'm going to have quantity x plus 72 times tangent 14 equals h. Now I put some emphasis on this quantity here to undo the x plus 72. Since it's dividing h, then I'm going to multiply it by both sides of the equation, x plus 72. But you have to have parentheses, because if you don't, you're saying only the 72 affects the tangent 14, and you don't mean to say that. You mean to say both terms do. It makes a big difference when you distribute. Okay, so make sure you include those parentheses. All right, so let's go ahead and distribute. This one doesn't require distribution. But I'm just going to, let's see here, I'm just going to carry this. Here I'm going to do x tangent 14 plus 72 tangent 14 equals h, right? And actually at this point, what I really want to do at this point, I could have actually done this earlier right here. I could say h equals h. Let me just do that. So h equals h. So basically you have this h, which is x tangent 35 degrees equal to this, and I went ahead and distributed it, which, like I said, I could have said h equals h here and then put this in place, but anyway, ends up being the same. Tangent 14, not sure, and then plus 72 tangent 14. All right, so why did we do this? Well, we did basically a substitution, right? We did this so that we went from two variables, h and x, down to one variable, x. But your one variable is here. And this here, 72 tangent 14, that's just a number. Tangent of 14, when you evaluate it, remember, you input is an angle, output is just a ratio of the two sides of whatever, the right triangle. That's just a number, and a number times a number is just a number. So this is just a number. However, this is not. This is a number, tangent 14, but then it's telling you how many x's you have. This is tangent 35. It's a number telling you how many x's you have. So now at this point, what I want to do is go ahead and get all the x's on one side and the number on the other. So what I want to do is subtract probably this one here. So let's do x tangent 14, subtract it from both sides. So on this side you have x tangent 35 minus x tangent 14 equal to your number 72 tangent 14. Now again, some of you might be asking me, well, why aren't you just evaluating this? Not evaluating it, I'm carrying it because rather than evaluating it and then approximating it and then going around and evaluating something else and approximating it, I'm going to make this much more precise, because this could just be a number and this could just be a number, and then I subtract the x's and be done, find how many x's I have. But I want this to be precise. That's why I'm carrying it. That's why I'm not evaluating anything yet. All right. So now what we have x here and x here. What I want to do is get x in one place. So what do? I factor. So what I'm going to do is I'm going to say x times tangent 35 minus tangent 14 equals my number 72 tangent 14. So this part was really, really important right here. Factor x. That's when it's important, right? So now you got x in one place. That's the whole idea. That's why you factor it. Now that you got it in one place, now you're going to be able to isolate it because you're saying, okay, what's affecting it? This stuff. And how is this stuff affecting it? It's multiplying. So how do I undo multiplication? Division. So I'm going to write it all out. I know it's extra work. It's for your benefit, not really mine. I'm going to divide by tangent 35 degrees minus tangent 14 degrees. And what I do to one side, I do to the other. So I have to do all this again, right? Tangent 35 minus tangent 14 degrees, right? And don't drop your degrees, by the way. All right, so now I have a product, so I can use the multiplicative identity. Those two cancel out. I am left with x is isolated. It's 72 minus tangent, no, 72, sorry, times tangent 14. But it's a good thing I have this thing, huh? That's a lesson for you too. Have one of those. All right. Or pencil, but you wouldn't be able to read this if I wrote in pencil. I actually prefer pencil. All right, so there we are. I've actually now figured this out. Now I'm ready to actually evaluate this. And the only thing I need to mention, I'll show you in the calculator what I did, what I'm going to do. But what you're doing is you're going to put in your numerator. It's all a product, so no problem there. Then you're going to have divided by, and you're going to have to use parentheses around this. Okay, otherwise you won't get the right answer. So let's go ahead and do that. And first, let's make sure we're in the right mode. We're in the right mode, degree. All right, so let's get out of here. And now let's put this in. 72 tangent 14 degrees, understood. Divided by, now here comes your first parentheses. So I put this in, here comes your first parentheses here. So we have tangent 35, close that up, minus tangent 14, close that up. And this is the really important part right here. So, you know, this parentheses closes that. This first parentheses closes the input to the tangent function. But this parentheses closes that. Now press enter. 39.81 feet. All right. So that's our answer for x, the width of the river. 39.81 feet. All right. Yeah. All right. So we're almost there. I think the next thing is you still have to find how tall the tree is, right? So we found the width of the river. We have to find out how tall the tree is. And from our picture, right, we let x be the width of the river and h be the height of the tree. So now at this point, probably the easiest thing is to, you could put it in a lot of places. I'd put it in here. So I'd say, well, h equals x, which is 39.81 times what? Tangent 35 degrees, right? And I get 27.88 feet is the height of the tree. All right, so this is width of river, and this is height of tree. All right. All right, thanks so much for listening. Practice a lot.